In our second video looking at survival analysis with SPSS statistics, we're going to introduce the life tables procedure. So this is a procedure which is probably the simplest survival analysis method in SPSS statistics, and therefore it's a good way to introduce the concept of survival analysis itself. It's a mostly descriptive procedure, and it's often regarded as appropriate when the time to event measure is recorded in quite broad ranges. These could be 6-month periods or even whole years. That means, of course, there's a lot that can happen within that period, so you tend to get a lot of ties among the data values. It's also used when there's not a lot of interest in differentiating between small time differences. It can perform significance tests comparing groups on a single factor, and it will also produce actuarial tables based on the time ranges. And as a result of that, life tables are often used in the insurance industry to estimate things like life expectancy and to set premiums. The example dataset we're going to use contains 1,000 rows of data, where each row represents a different customer or service subscriber to a telco firm. The time to event variable in this case happens to be their tenure as a customer, how long they've been a customer, and the event variable denotes whether or not they cancelled their subscription or stopped being a customer, in other words, whether or not they churned. And now there are a number of additional variables, including things like gender and customer category. And the sample file itself, if you wanted to take a look at it, is called telco.sav, and it's actually included in the samples folder where SPSS statistics is installed. So here we have our telco.sav sample dataset. We can see that there's 1,000 rows of cases in there, and we can also see what our key variables are that we need to pay attention to. There's lots of additional variables here, but there's really two key ones we want to pay attention to. The first one is this variable churn, which simply indicates whether or not they have churned within the last month. So we might just do some descriptive stats on that. We can see that 27% of them churned within the last month. So that's kind of giving us an idea of how many people, if you like, did not survive. And then we have our time variable. Time variable is back over here. This is tenure, which is basically measured in months. So it's months with service. We right click on that and hit descriptive statistics. We can see that it actually runs from a minimum of 1 month. Some customers only been with the service 1 month. Some have been a maximum of 72 months, with the mean survival time, if you like, the mean number of months they've been in the service is 35. Okay. Let's have a look at how we analyze that using the life tables survival analysis procedure. We go down to analyze, survival. There's all the different survival procedures there. We click on life tables, and we first of all configure the time variable. The time variable, as we saw, is tenure, months with service. And we could say 0 through 72. At this point, that means just use the first 72. We know that 72 is the maximum. We can say we want to look at that range of data, or we could say, well, actually we're going to restrict it down to 60. Let's take it down to 60. Just look at the first 60 months of customer survival up until that point. And we could say every single month, so by 1, or we could say by 3, and look at in time periods of 3 months if we wanted to. So this is something that life tables kind of almost expects people to do, to have less granular approach to analyzing the data. And it's partly because it's actually going to punch out individual tables, and it might be a bit overwhelming if you're doing it at too fine a degree of granularity. So we can go for a slightly coarser degree of granularity. Instead of looking at every month, we can look at every groups of 3 months. And then we need to point out what the status variable is. The status variable is churn, and remember, what is the code for people who churned? The code for people who churned is code 1, so that indicates that they have churned. That's our terminal event, and we can say, want to look at single value 1. As soon as we do that, we can click OK. If we just go to options here, we can ask it also for a survival plot to be created at that point. And if we click continue and OK, it'll run the survival analysis for us. Okay, before we focus on the output, let's just remind ourselves how we generated that output. This is how the life tables procedure was set up in our dialog. We had time specified as the variable tenure, months with service. We asked it to look at the first 60 months of data, and we asked it to do it by groups of 3, so 3 months at a time. The status variable was our variable churn, with 1 indicated as the event category where churn they did actually churn within the last month. And then we clicked on options and asked it to give us a survival plot as well. If we look at the output that generated, we can just focus on the first main bit of output, which is the life table itself, and walk you through some of the detail of that. So the first thing we notice here is we have the elapsed time. This is interval start time. This is basically the tenure variable, and as you can see, it's in groups of 3. So it starts at 0 time, basically starting at the point when all the cases are available. Nobody, as we know, has a tenure of 0. The minimum tenure is 1. Then it has a number of records entering the current time interval. So that's basically saying we start with 1,000 records. And then it says the number withdrawing during that interval. So what is that interval? Well, it's actually 0 up to 3. So it's basically the first 2 months. And it's saying that 7 records withdrew during that interval. What they mean really is that 7 records were censored. In other words, 7 records had a tenure of 2 or 1. And we know no more information about them at that point, so we can't say anything else after that. The next thing, it says number exposed to risk. This is basically the number of surviving cases minus 1/2 of the censored cases. It's just a convention of showing how many cases it estimates are still exposed to the risk at that point. The 5th column is the number of terminal events. That's not the number of censored events. So it's basically saying that within the first 2 months, 13 cases were actually churned. So these were service cancellations. So that's the number of cases which were met that terminal event condition. And then we have the proportion terminating. What proportion actually terminated within that first 2 months? Well, it's a very small proportion, of course. It's 0.01. It's only 13 cases, and it's 13 cases as a percentage of as a proportion of 1,000 cases rounded, and if we round it, it comes out as 0.01. Which leads us with the proportion who are surviving, which is 0.99, so 99% of the cases surviving, and then the cumulative proportion of cases still surviving at this interval. So this is just a cumulative counter, and you can see it's starting to go down, of course, as more people actually churn, as we would expect. So by the 24th month interval, we're down to 80% surviving. The standard error, well, standard errors are just an estimate of variation, so it kind of gives you an indication of how reliable that value is based on the number of cases available. And then an estimate of the probability of experiencing the terminal event during that time interval. So it's just saying, look, you got about 0.01 chance of experience, so about 1% chance of experiencing the terminal event there, and about 0.5% chance here, etc., etc. 1.4% chance within this 3 to 6 month period, which is just month 3, 4, and 5, etc. And then we have standard error of that again, an estimate of variance of the probability. If it's not a very reliable probability because it's not based on a lot of cases, for example, the standard error gets larger. And if it's fairly reliable, it's based on a lot of cases. We have 1,000 cases here, it tends to be smaller. And then we have what's called the hazard rate. So this is an estimate of the risk of experiencing the terminal event during the interval, conditional upon surviving to the start of the interval. In other words, it's the risk of the event occurring in that interval given that the subject has survived thus far. So we're saying there's like a 1% chance here, or roughly, given the fact that you've got to the 18-month interval, you've got about a 1% chance. So it's slightly different from the survival rate, which is just how many have survived that point, or the cumulative survival rate, which is just the cumulative version of that. It's actually saying, given that you've survived that far, this is the probability, an estimate of risk of you churning off the terminal event occurring. And then we have a standard error of the hazard rate. Again, not terribly interested in this case. It's quite a small number, and it's certainly so small that we can't display it in this last column. So that is the life tables output that you generate. It's just basically telling you how many cases have experienced a terminal event, how many cases are remaining, how many cases are censored, and providing cumulative counts of that. And very importantly, it's given us a cumulative survival and also a hazard rate, which is the probability of or the risk of that event occurring, given that the subject has survived thus far. Lastly, we have the survival plot itself, the cumulative survival plot, the survival function. And this is effectively a line chart of the values displayed in column 8 of the life table's output. Here's column 8, which is the proportion who are surviving. So it starts at 0.99, which is like, you know, nearly 100% surviving within that point, that first time interval. And of course it falls by interval 24, you're down to 80%. This is just reflecting that. You can see these stepped groups at this point, because of course we're doing this in 3-month intervals, and we can see the decay, what proportion are left at that point. Bear in mind, of course, it doesn't go from 0 to 1. It actually starts around here, just below 0.6, so just below 60% mark. And this is the months of service. Of course, again, we asked it just to limit it to the first 60 months, not to include all 72 months. But that's effectively a survival function plot showing the remaining cases that are surviving. Let's have a look again at life tables, but this time let's add in another variable and just request a few extra bits to do a deeper analysis. Returning to the survival analysis procedure we ran earlier, we just go to analyze survival down to life tables. And previously we were really only looking at sort of one-dimensional survival analysis. We're looking at the relationship between time and status. So we're really analyzing the survival function itself. We can add in another factor here. So we can add in a factor such as customer category. This indicates what type of package or service the customer was on, subscriber was on. So we can see that there are 4 different packages here. You have basic service, e-service, plus service, and total service. And we can add that as a factor and go to define range here and say, okay, it's a 1 to 4. That means include all 4 groups. And if we go to options here, we can actually ask for a test to say whether or not these groups are statistically significantly different from one another in terms of their survival chances. Let's click OK and work through the results of that. So one of the things we notice is that the life table itself is much larger this time. That's because it's showing us the life table for all 4 groups: basic service, e-service, plus service, and total service. So we can make that a bit easier to view by double clicking on it and calling up the pivot tables option here and just putting this category, service category variable into the layer box. So now we can see this is for basic service. So let's just look at the midpoint here. So we have basic service. It's saying, okay, what's the cumulative proportion surviving? So around about 24, 27, I think 27 months at this point. It's 0.69, about 70%. What about for category e-service? Same point here. It's 0.83, so quite a big difference there. For plus service, about 27, it's 0.9. And for total service, it's back to close to 0.69, 0.7 here, 70%. So there's some differences there in the survival chances, certainly at the midpoint or thereabouts, for different groups or people in different packages. We can see that much more obviously illustrated when we look at the actual survival function plot here. Look at this. So we double click on this. Here is the basic service down here. You can see that they have the worst survival, and the best survival is those on the plus service. And the difference, the ones that's closest to the basic service, is actually this one here, which is total service, quite close to that. Now, we might ask at this point, are they statistically different from one another, or are they significantly different? And it turns out we can do this little test here, which is comparison for control variable customer category. It's showing the significance value is less than 0.05, so it's saying yes, that somewhere within these 4 groups there's statistically significant difference. So it's at least between basic service and plus service, which are the sort of minimum and maximum. But if we rerun the analysis and ask it to do what's called pairwise comparison and hit continue, it'll rerun that analysis, but it will actually compare each pair, each grouping, if you like, of these different customer categories. So there's one against 2, That's statistically significant, less than 0.05. 1 against 3, and 1 against 4. 1 against 4 is not statistically different. Now 1 against 4, just to remind you what that is total service versus basic service. It's these two groups here. It's saying that these two groups here are not statistically different from each other. And then if we look at 2 against 1, significant, 2 against 3, significant, 2 against 4, all less than 0.05, 3 against 1, significant, 3 against 2, and 3 against 4, significant, and then, as we'd expect, 4 against 1, not significant. It's just a mirror image of the first contrast pairwise comparison. So we can go into some level of detail here where we can say, okay, let's look at the survival function. Let's break the survival function down by different groups. Let's see if the survival function is affected by another group. We could rerun this again and add in yet another variable such as gender here, and do it. And now we'd end up with even more permutations, if you like. It would be the equivalent of doing what's called a split file analysis in SPSS. But it gives you an idea of what sorts of things one can do with life tables to establish survival, and how that changes over time, where the inflection points are, how to calculate the probability of survival at a given point in time, and also to test whether or not survival is affected in a quite straightforward way by a third variable, by another independent variable.